maximum value of the function. We have it as y equal to 2x³ plus 3x² minus 72x plus 1. To get the maximum value, there are some steps you must follow. First, find the first and second derivative of this function. Secondly, find the stationary point. At stationary point, the y over the s is equal to 0, which is the first derivative is equal to 0. Then at maximum value, the second derivative will be negative when you substitute the value from stationary point, while the minimum value will be positive, but we are asked to find the maximum value. So we are looking at the value where the second derivative will be negative if the value of s in the stationary point is substituted. So let's go. First derivative, the y over the s will be equal to 3 times 2, 6s, 3 minus 1, 2, plus 3 times 2 again, 6s, 2 minus 1, 1. Then minus 1 times 72, 72. 1 minus 1, 0, and 3 plus 0 is 1. So 72 times 1 is 72. Second derivative, the square y over the s square. So to get the second derivative, you also find the y dx of the first derivative. 2 times 6, that gives us 12s, 2 minus 1, 1, plus this 6. What is the next thing to do? Find stationary point. Stationary point. At stationary point, the y ds equal 0. So substitute 0 for the y ds. We now have 6s squared plus 6s minus 72 equal 0. Dividing through by 6. 6 can divide everything here. That will give us s squared plus s minus 12 equal 0. Look for two numbers you multiply to get minus 12. And if you add it, you get plus 1. That will give us 4 and minus 3. 4 times minus 3 is minus 12. 4 plus minus 3 is 1. So it's satisfied. So that will give us s squared plus 4s minus 3s minus 12 equal to 0. If you check very well, you see that 4s minus 3 is equal as s. So we are in order. And 4 times minus 3 minus 12, we are in order. So factorize this first two terms. We now have s is common, remaining s plus 4. Factorize it again, minus 3 is common, remaining s plus 4. So that minus times plus is minus. 3 times 12 equal to 0. So we now add that s minus 3, then s plus 4 equal to 0. Once you multiply two numbers and you get to 0, either one of the numbers equal to 0 or both numbers are 0. We don't know which one, so you write either s minus 3 equal to 0 or s plus 4 equal to 0. S is equal to 3 or s is equal to minus 4. These are the two stationary values for s. To get the maximum value of the function, second derivative, once you do these two into the second derivative, you're going to get less than a value less than 1. Less than 0. So let's substitute s first. So the square y over the s square when s is equal to 3. What would that give us? Look at the value of the square y over the 12s plus 6. We now have 12 into 3 plus 6. That will give us 12 times 3. That is 12, 24, 42. 24, 36. 36 plus 6, 42. So here will give us 42. Then you also find the value of the square y over the s square when our s is equal to minus 4, the second value. Let's see. That will give us 12. Place of s equal minus 4. Then plus this. 12 times minus 4. 24 is minus 48. Minus 48 plus 6. That is minus 42. So this value give us negative. So this value of s equal to minus 4 would give us the maximum value of the function. So y maximum will now be equal to, look at the value of y. the maximum will not be because when s equal to -4. So when you see s now put -4, that will give us 2 into -4 raised to power 3 plus 3 into -4 raised to power 2 minus 72 into -4, then plus 1. Y maximum will be equal to 2 into minus times minus times minus, that is minus 4 raised to power 3, it will be 64, plus here we have 3 minus 4 times -4 is 16, minus times minus is plus 42 times 4, 288, 288, then plus 1. Y maximum will be equal to, this will give us minus 128 plus this is still 32, 32 plus 16 again, that should be 48 plus 288 plus 1. So our Y maximum finally will give us minus this plus this plus this, that will give us 209. So the maximum value of the function is 209. Please let's follow up Fine Brain or the brain